Hello, algebra students. Today we're going to look at section 10.2, solving inequalities. So you want that template out. The first statement that we have here is called the property of comparison. And we have some symbols that I want to describe for you. That first little symbol, that's an upside down A, that stands for the phrase for all. And then we have A and B, just variables standing for numbers. And then the little E, elements of. So that are elements of. And then that one you should know, the real number system. So the real numbers. So then we have a complete statement there. For all A and B, they're elements of the real numbers. One and only one of the following statements is true. So we have if A can be less than B, A could be equal to B, or A can be greater than B. So you can only have one of those true at any one time. So based on our discussion of the symbols, this statement here reads, for all A, B, and C that are elements of the real numbers, then if A is less than B, then A plus C has to be less than B plus C. So it kind of looks like ALE, but then we're dealing with inequalities and not equations. And if A is greater than B, then A plus C is greater than B plus C. So it's really just stating that if you're adding the same things to both sides, then the inequality keeps its relationship. So for our examples, we have 3 less than 6. Well, what if we add the same number to each side? So let's take a look at that. If we have 3 and if we add 4, just as a random number there, and we keep the less than, and then 6, and we add the same thing, we add 4 to the other side. So if we add the same thing to both sides, we get 7 on the left and 10 on the right, and 7 is less than 10. So the relationship stays true when we add the same thing to both sides. Let's look if we subtract and see if that holds true as well. So we have 3 is less than 6, 3 minus 4, so we're really adding negative 4, and 6 minus 4, and we're kind of comparing here to see if that holds true. This would give me negative 1, and this would give me 2, and negative 1 is still less than 2. So again, the relationship holds true. So the next relationship we're looking at is the multiplication property of order. So looking at this statement, so we have for all A, B, and C that are elements of the real numbers, and we're going to take a look at what that means in detail. If C is greater than 0, or in other words, C is positive, because we've got positive numbers are greater than 0, then we can say if A is less than B, then AC is less than BC. If A is greater than B, then A times C is greater than B times C. So we're multiplying by the same thing on both sides, and the relationship holds true. And then we move to if C is less than 0, that means C is a negative. So if we have A is less than B, then AC is greater than BC. So just taking note there that we changed that symbol, and we'll take a look at that in a moment. So if A is greater than B, then AC is less than BC. So again, taking special note to see that we flip that symbol around. There's a reason for that. Let's take a look at our examples. To look at this in examples, we're going to take the sentence -4 is less than 3, and we're going to multiply by 2, a positive. So we're going to say, okay, we're going to multiply -4 times 2, and we're kind of looking at the relationship between that and 3 times 2. -4 times 2 is -8. 3 times 2 is 6. -8 is still less than 6. This is true. So we multiply by a positive, and the relationship stayed the same, and it stayed true. We look at example B. This time we're multiplying by a negative. So we have -4 times -2, and we're looking at that compared to 3 times -2. Started out as less than. -4 times -2 is a positive 8, and 3 times -2 is -6. But if I try to put the less than in there, well, 8 is not less than -6, so I've got to get rid of that and say, flip it around, 8 is greater than -6. When we multiply by a negative, it changes the inequality. For the next statement, we're looking at the transitive property of order. So for all real numbers, A, B, and C, if A is less than B and B is less than C, then A must be less than C. If C is greater than B, and B is greater than A, then C must be greater than A. So let's put that into some actual numbers. I think it's easier to think about. So if 6 is less than 7, and 7 is less than 9, then 6 also has to be less than 9. Not rocket science, but just kind of building that algebraic relationship. So in example 1, we're going to look at solving the inequality. Now our rules for solving the inequality are basically the same as solving for equations, except we need to keep that multiplying rule in mind where it would flip the relation symbol. So to start getting our variables to one side and constants to the other, I'm going to add 3 to both sides. That gives me the new equation of -6 is less than 10 minus 4x. I'm going to add 4x to both sides. This process should be familiar to you. I get -2x is less than 10. I'm going to divide by -2, divide by -2, x. Now we have to watch here because we are dividing by a negative. That's like multiplying by a negative, but this is the reciprocal. And so that means we have to flip the relation symbol. So we're going to change the relation symbol to greater than, and then we do the dividing on the right and get -5. So we can write our solution in a couple of ways. We use our solution set, and we would say x such that x is greater than -5. And then we can also graph our solution set. So we're going to do a little number line. We want -5 on our number line, and then we want a couple of reference points. So I'm going to put 0 and +5 so we can see our direction. And greater than -5 means -5 is our boundary, but it is not included. So I want an open circle. And then greater than means I am shading to the right. And there's my solution set on a number line. For this next example, I'd like you to solve. You're going to enter your solution onto Edpuzzle and then continue the video. You should have gotten x is greater than or equal to 3. There's no multiplying or dividing by a negative, so we keep the relation symbol the same. And then we're going to write our solution set. So we've got x such that x is greater than or equal to 3 in our solution set. And then to graph that, I'm going to put 0, 3, and -3 on our number line. And because it's or equal to, then the boundary of 3 is included, so we want to fill that circle in. And again, greater than means I am shading to the right, and that's our solution set on a number line. So we're going to solve our inequality here and then show a check for it. So I'll take you through the checking process. So the first thing I'm going to do is subtract 4 from both sides. I want to get my constants to both sides, to one side there. So I get -8 is greater than or equal to -u over 2, or u over -2, which would be the same idea here. So if you prefer to write that in that way, I think that's easier to think about. And then to get rid of that denominator of -2, you're going to multiply both sides by -2. Now remember, when we're multiplying by a negative or dividing by a negative, we need to flip the relation symbol to keep it true. So this gives us +16 on the left. We're going to switch our relation symbol to less than or equal to, and we get our u left over. So u is less than or equal to, or 16 is less than or equal to u. Now because 16 is on the left, when we want to rewrite that as u, we want to rewrite it with the variable on the left. So we would say u is greater than or equal to 16. So we're just kind of reading that statement from the right to the left, and we rewrite it from left to right, and that requires us to kind of flip that relation symbol back around. So then we have our solution set of u such that u is greater than or equal to 16. And if we're going to check that, we'll put that on a number line. So I'm going to put 0, I'm just going to put 16, -16 for a reference. The or equal to means that that is included, so 16 is included. I'm going to put a closed circle there. Greater than means I'm shading to the right. And then we want to do a check for this. To do a boundary check, you're checking like the borderline number. So in this case, that would be 16. To do a boundary check, you check the equation with like the boundary answer, and the results should be equal to each other. So when we're doing a boundary check, we're looking for things to be equal. So we're going to take our inequality and say, okay, -4 is equal to 4 minus 16 over 2. So again, we're looking for that to be equal when we're doing a boundary check. And so we say -4 is equal to 4 minus 8, and of course -4 is equal to -4, so that is a good check. And that tells us that our boundary number of 16 is a good boundary. To do a side check, we're checking that we shaded to the right direction. And to do a side check, we want to choose a number that would make the inequality true. So we're picking something that falls in our shaded side to make sure we shaded to the correct side. So for this, since we shaded things greater than 16, let's just let x equal 20. That's greater than 16. You could choose anything on your shaded side. I'm going to pick 20. So we would say, okay, negative 4 is greater than or equal to 4 minus 20 over 2. So I'm just plugging in 20 for my variable to see if it holds true. And so negative 4 is less than or equal to 4 minus 10, greater than or equal to. And then negative 4 is greater than or equal to negative 6. Negative 4 is greater than or equal to negative 6. That is true. So again, that is a good check. So now I've checked my boundary, and I've checked that I shaded in the correct direction. So let's take a look at what would have happened if we had done a side check in the unshaded part. Like, so if we had solved and we got the wrong shading and we picked something. So we're just going to let x equal 0 and plug that in. So we've got negative 4 is greater than or equal to 4 minus 0 over 2. So again, we're plugging in 0. We're looking on the wrong side of the shading. And so we get negative 4 is greater than or equal to 4 minus 0. And so that gives us negative 4 is greater than or equal to 4. Well, negative 4 is not greater than or equal to 4. That is false. So if we end up checking and we get a false statement, it just tells us that possibly we shaded to the wrong side, so we've got to go back and look at our work. So when we're solving equations, we know that we can have some special solutions, and that can happen with inequalities as well. So let's take a look at this first inequality. If we solve the inequality, we're going to subtract 4 from both sides. That gives us 2x is greater than 2x minus 3 or plus negative 3. And then I subtract 2x from both sides. And I get 0 is greater than negative 3. Now 0 is greater than negative 3, but my variable terms have disappeared. This is a true statement. When we get a true statement in an equation, and we get a statement that's true with no variables, it's all real numbers. And that is true of inequalities as well. So where variable terms cancel out, we get 0 is greater than negative 3, which is true. So the solution set is all real numbers. So we'll look at our next example here. I'm going to subtract 5 from both sides. We get 2x is less than 2x minus 2. Subtracting 2x from both sides. Hopefully you can kind of see what's going to happen here. We get 0 is less than negative 2. And that is a false statement. 0 is not less than negative 2. And just like when we solve equations, when we're solving inequalities, if we get a false statement after the variables cancel out, then the solution is no solution or the empty set. Remember to take all your questions into class.